Hello and welcome to today's lesson where we're going to look at radiation and absorption, which is part of the waves topic in GCSE Combined Science Physics. So in today's lesson we're going to try to understand how different objects emit radiation. So we can detail the process of emission and absorption, we can understand the emission and absorption rates of different objects, and we can experimentally prove emission rates of objects and analyse experimental data. We will have been successful and learned in today's lesson, which is part of the following part of the GCSE Combined Science Specification for Physics. It's the properties of electromagnetic waves, in particular investigating how the amount of infrared radiation absorbed or radiated by a surface depends on the nature of that surface. So we can describe objects as either hot or cold, but why do we feel an object to be cold and why do we feel an object to be hot? Well, objects feel cold if they absorb more infrared radiation than they emit infrared radiation. So this process will cause an object to gain temperature because it's absorbing or taking in more radiation or energy than it is releasing or emitting. Now, objects feel hot if they emit more infrared radiation than they absorb infrared radiation. Now, this process will cause the object to lose temperature as it's releasing or emitting more energy than it is taking in or absorbing. Now, objects are in thermal equilibrium if they emit as much infrared radiation as they absorb. So if the emission rate and the absorption rate is the same, the temperature of an object stays constant. So all bodies or objects, no matter what temperature, emit and absorb infrared radiation. The hotter the body, the more infrared radiation it radiates or emits in a given time. Now, a body at constant temperature emits more infrared radiation at the same rate as it absorbs it. The temperature of a body will increase when the body absorbs radiation faster than it emits radiation, and the temperature of a body will decrease when it emits radiation faster than it absorbs it. However, if all of these blocks on the screen are at the same temperature, would they emit the same amount of infrared radiation? Well, they would not, because as well as temperature being a factor of the rate of emission and absorption of radiation, colour is also a factor that affects emission and absorption. So the emission and absorption is affected by both the temperature and the colour of a surface. So as these objects are different colours, they emit and absorb radiation at different rates because they have either a black colour or a silver colour. Now, black objects are good absorbers and emitters of infrared radiation, while silver objects are poor absorbers and emitters of infrared radiation. So the blacker an object, the more radiation it absorbs and emits. So all bodies, no matter what temperature, emit and absorb infrared radiation. The hotter the body, the more infrared radiation it radiates in a given time. Now, different substances may absorb, transmit, reflect or reflect electromagnetic waves or infrared radiation in ways that varies with their wavelength. Now, some effects, for example refraction, are due to the difference in the velocity of the waves in different substances. Now, you should be able to construct ray diagrams of refraction of a wave at a boundary between different media, and finally you should be able to investigate how the amount of infrared radiation absorbed or radiated by a surface depends on the nature of that surface. So if we've been successful and we've learned in today's lesson, we can detail the process of emission and absorption, understand the emission and absorption rates of different objects, and experimentally prove emission rates of objects and analyze experimental data. So I hope you've enjoyed today's lesson where we've looked at radiation and absorption, which is part of the GCSE Combined Science subject of physics in the waves topic. Thank you very much for listening and have a lovely day.